Hi all. This is very much an overview of the biomechanical and segmental exam of the thoracic spine. It'll include the spinal joints and the costal joints, but as I say, it is an overview. There's no detail in this, or very little detail anyway, and you'll find it's not that much different from the other areas of the spine. Okay, we're going to concentrate on mobility testing, and I'm going to ignore stress testing as I don't think it's particularly useful in the spine. Your instructor at this level may feel differently, but that's the way I feel. Anyway, we can use position testing, and it has the same significances and the same procedures as we use in the lumbar spine. In fact, it's a little easier to fill here in most instances. Extension between the scapula can be a bit difficult if you're resting on your elbows because the muscles bunch together. These are often better done with you laying flat on a bed with your chin on the bed. So you extend the thoracic spine through the neck, which is possible simply because the thoracic spine has so little movement in it. Excuse me. But otherwise, it all means the same thing. So we're looking for an asymmetrical position of the vertebra, that is, an abnormal rotation as it tries to flex or extend. So the side that's moving more may be moving more because the other side is less mobile, or it may be moving more because it is more mobile. No different from the lumbar spine. You follow this up again with P-pivums. Now, P-pivums can be done by doing derotating the vertebra, that is, pushing forwards on the posterior transverse process, either to extend the opposite side or to try and flex the same side, the same as it was in the lumbar spine. Or we can do P-pivums in sitting and actually going through the range of the flexion, extension, rotation, and side bending. Or, which is usually a bit easier, is to do them in combined movements. So we basically take the spine into the quadrants. Now, if you're doing the upper spine again, you simply have the arms either on the back of the neck or across their shoulders, and you move the arms to move the upper thoracic spine. For the rest of the spine, you basically flex and extend or lower down. You can kyphos and lordos to get the same movements. But the P-pivums have the same significance again. If you find a high mobility there, then you follow up with pavums, which again is going to be superior or inferior. So there is no change in the principles of mobility testing in thorax compared to the lumbar spine. It's just a difference in the detail on exactly how you do it. Okay, so here's a bit of an algorithm on the processes of biomechanical examination. First square is saying that you must make the diagnosis before you do the exam. You do not make the diagnosis of a biomechanical dysfunction via the biomechanical exam. You will find everybody in your class has biomechanical dysfunctions which are not painful. So this may not be what's bringing them in. You have to go by the signs and symptoms and the range of motion test and all the other tests that go along with this to make that diagnosis. Once the diagnosis is made, you then use a biomechanical examination to refine, localize it. So we start off with either symmetrical or asymmetrical P-pivums. The asymmetrical P-pivums can be taken from position testing followed by P-pivums and pavums, or they can be done in the form of combined movements where you're doing an asymmetrical type movement. Symmetrical movements, symmetrical testing is flexion, extension, side bend, and rotation. It's not that one side is doing exactly the other side, but they're mirror images of each other, so they are symmetrical in one dimension. Now, you have to use symmetrical testing when the P-pivums are negative. Because you have an asymmetrical dysfunction that is not going to be amenable to asymmetrical testing. So your P positions won't work, but your combined P-pivums will. You can go either way you want to. If these are positive, you then move on up the algorithm up to pavums, and these are superior and inferior gliding. If they're negative, you come down or across rather into costal testing. but let's stick with the PAVMs for the moment. If these are positive, then you can go straight to treatment, but it's worth noting that the fact that the spine is dysfunctional hasn't disproved that the costal joints are dysfunctional. So they should still be examined, particularly if you decide not to examine them and things don't get much better. But you're better off doing a full examination of the costal joints as well. So whether the PAVMs are positive or negative, you will examine the costal joints. But if they're positive, you can treat the spinal joint problem, in which case the results of your PPIVM or PAVM on the costal joints are much more likely to be accurate and not affected by muscle tone from the spinal joints. So treat the PAVMs first, but always examine the costal joints anyway. Certainly, if the PAVMs are negative, and as they should be if the PPIVMs are negative, if the PAVMs are negative, then you have to go to the costal joints. You've now got tone changes, probably, if it's not scarring, you've probably got tone changes which can be caused by the costal PAVMs, by the costal dysfunctions. So do your PAVMs here. I wouldn't worry too much about doing PPIVMs on these joints. Especially if you've done, if you treated this spinal joint first, any tone changes should improve as you treat the cause of it. But if you've done that, then the costal PAVMs are what you need, not the PPIVMs to the ribs. They can be fairly unreliable. Anyway, the PAVMs are definitive. If the PAVMs are positive, we can go up and treat them. As the algorithm shows. If they're negative, then you need to either review the entire examination all the way back to the diagnostic one. You may have made a mistake in saying this is a biomechanical dysfunction, and if you're quite happy this is biomechanical dysfunction after you review the diagnostic exam, then review the biomechanical exam, and if you're still finding negative stuff, get a second opinion on it. So either you've mistaken the diagnosis of biomechanical dysfunction, or you're just not picking up the diagnostic dysfunction. Either way, you need help with this. So get it. Don't be too proud on this. Okay, so a very short overview of the biomechanical exam of the thoracic joints, and it can be short because this is built on what you know from the lumbar spine and the cervical spine. So we don't need to go back into that foundational stuff that we used before. Just a word about the comparison between the two. You are better off comparing the thoracic spine with the cervical spine than with the lumbar spine, simply because you have the equivalent of unconvertible joints here. The unconvertible joint being the costotransverse junction. The head of that rib reaches up into the superior vertebra. So, and these make it act much the same way as the cervical joints. The cervical spine does. That is, when you side bend to the right, it all translates to the left based on these two projections up into the next vertebra. So hope this helps and we can discuss it. Take care, everybody. Bye-bye.